Welcome viewers. This is lecture number 8 of lecture series on real analysis. In this lecture we are going to discuss about sequences, and the concepts covered in these lectures are definition of sequence, range of sequence, bounded sequence, and examples based on uh, sequence, range of sequence, and bounded sequence. So let us start our discussion with sequence. So what is sequence? A sequence is a function a sequence of real numbers is a function x from set of natural number to real number r defined by x of n, x of n. N is, you can take any natural number defined by, that is, xn, such that this n belongs to set of natural number. So it means in a sequence the domain must be a set of natural number and its codomain is set of real number. You can take a subset x of a real number r also. So, but codomain must be real, because we are talking about real sequence. So, if codomain is complex C, set of complex number C, then it is a complex sequences. So now, because we are discussing about real sequences, so we are taking codomain set of real number R. So now, image, range of range of sequence. So range of sequence is image of x, that is image of image x, that is equal to range of the sequence. Or in other words, we can say that range of the sequence, by definition we can say the set of all terms of the sequence, the set of all terms of the sequence. Repeated terms we are taking once, so the repeated terms taken once. Repeated terms taken once is known as the range of the sequence. Bounded sequence, a sequence xn, a sequence xn is said to be bounded in R, bounded in set of real number R, if there exists m greater than 0, a positive real number m, such that for all n in n, mod of xn must be less than equal to m. If mod of xn is less than equal to m, then we can say the sequence is bounded sequence. Or in term of quantifier, in term of quantifier, we can write it write it as there exists m greater than 0 such that for all n belongs to natural number such that mod of xn is less than equal to m. So this is, and geometrically how we can define this set of how we can define the sequence is bounded. Let this be a set of real numbers. There is a positive number m, so m is here and minus m lies on this real number. So uh, all the terms of the sequence, whatever n you can take, how how large you can n you can take, all the terms of the sequence lies within minus m and n. So all x lies in, for all n in n, xn lies here, xn lies here. So then we say the sequence is said to be a bounded sequence. So let us discuss some examples. Uh, yes, one thing that we xn sequence xn is denoted by is defined by xn. N means set of natural number. You can take any number, 1 2 3 4 and so on. Respect to with respect to each term you get xn, where n belongs to natural number. For example, the sequence xn can be written as, that is x1, x2, x3, x4, x5 and so on, xn and so on. Here, or you can take xk and so on. Here this x1 is the first term of the sequence, first term. This x2 is the second term. This x3 is the third term, and similarly this is the fourth term, this is the fifth term of the sequence, and this is the kth term of the sequence, kth term of the sequence. So in this way we can write, if we have to find the nth term of the sequence, then we have to find by putting k equal to n. So examples. So first example, let xn is equal to c for all n in n. So what is the sequence? How we can define the sequence? So sequence xn, that is equal to whatever x, x1, x2, x3, x, you can take xk and so on. So if we put x1 and n equal to 1, then again we get c, x2 is also c, x3 is also c. So all the terms are c, all the terms are repeated. So now what is the range of this sequence? Range of the sequence xn. Yes, can anybody tell me what is the range of the sequence? Yes, it is a singleton set C. Yes, very good. It is a singleton set C. So because all the terms are repeated and repeated terms are taken once, so it is the range of this sequence is a singleton set C, and we also call this sequence as constant sequence. Constant sequence. So if all the terms are repeated, then it is a constant sequence. You can also, if we take the particular case of this constant sequence, if we take xn is equal to 1 for all n in n. So what is the sequence? It is 1, 1, 1, 1 and so on. So what is the range? Yes, quickly. Very good. It is singleton z1. So range of this sequence is 1. Now second example, if we take xn is equal to minus 1 की power n plus 1 for all n in n, then what is the sequence? The sequence xn is, put this is x1, x2, x3, x4 and so on x. If we have to find the nth term, then it is xn. So when we put n equal to 1, n equal to 1 here, then we get minus 1 की power 1 plus 1, it is 2, so it become 1. When we put n equal to 2, it become minus 1 की power 3, it is minus 1. Similarly, you get 1, minus 1, 1, minus 1 and so on. Now, can you tell me what is the range of this sequence? What is the range of this sequence? This sequence xn. Yes. Can anybody tell me what is the range of this sequence? Yes, very good. The range of this sequence is minus 1 and minus 1. Now, again, a question to all of you, whether the example number 1 and example number 2 that we have discussed, both are bounded or not. Example number 1 and example number 2, both are bounded or not. So we will discuss later on. Now, but you think about it. Now come to example number 3. Let xn is equal to one upon n for all n belongs to natural number. Then what is the how we can define the sequence? So sequence xn, that is equal to x1, x2, x3. You can define the kth term xk, or you can also define the nth term by xn. So what is x1? X1 is the first term. We put n equal to 1, so we get 1, 1. When we put 2, it becomes 1 by 2, 1 by 3, 1 by k. 1 by k is the kth term of the sequence. So this is the sequence. So what is the range of the sequence? Range of the sequence xn. So range of the sequence xn is 1, 1 by 2, 1 by 3, 1 by 4. So can I write like this? This is 1 upon n, such that n belongs to natural number. So it is same as 1 comma 1 by 2. So range of this sequence is this sequence bounded? Is this sequence bounded? Again, a question to all of you. Now, fourth one. Let xn is equal to 2 raised to power n for all n in n. Then what is the sequence? How we can define sequence? So sequence xn is x1, x2, x3, x. If we take the nth term, then it is xn. So x1 is 2 raised to power 1 is 2, 2 का square, 2 का cube x3, xn is 2 raised to power n, and so on. So in this way we can find. So what is the range of the sequence? The range of sequence xn, that is 2 raised to power n, such that n belongs to natural number. You can also write 2, 2, comma 2 ka square, comma 2, 2, but it is the best notation. Yes, again, is this sequence bounded? Now, fifth one is next example. If we take, let xn is equal to n for all n belongs to natural number. Now, quickly define the sequence. You can pause the video and write down the sequence, and after that you find the range of the sequence. And third is the sequence bounded or not? So now let us define how we can define the sequence. This is x1, x2, x3. These are all the n terms of the sequence. X1 is the first term, x2 is the second term, and so on. So when we put x1 n equal to 1, when x1 is 1, when we put n equal to 2, it is 2, 3, and so on, and so so this is the sequence. Now what is the range of the sequence? The range of the sequence xn. The range of the sequence is 1, comma 2, comma 3, comma 4, up to so on. So I would like to write in this way, n, so that n belongs to natural number. So this is the range of the sequence. Now let us take another example. Xn is equal, let x1 is equal to 1, and xn plus 1 is equal to under root 2xn for all n in n. So now we have to find the sequence xn. Xn is x1, x2, x3, x4, and so on. So in this case, because first term is given, second, third, and fourth term we have to put n equal to 1, 2, and 3 in this expression, then we get x2. So put n equal to 1, then we get n x2 is equal to under root 2 x1. So x1 is already given, so it is 1, so it become under root 2. So x2 is under root 2. Now x3, put n equal to 2 here. So x3, n equal to 2 means under root 2 x2, and x2 is nothing but under root 2, so it is under root of 2 under root 2. Similarly, you can find x4. X4 by putting n equal to 3 here. So x4 equal to under root 2 x3. Under root 2 x3. And x3 is under root of under root 2. Under root 2 of under root 2. So under root 2 under root of 2 under root 2. So it is like this. Similarly, you can find x5, x6, and so on. So let us put all the values here. X1 is 1 given, x2 is under root 2, x3 is under root 2 under root 2, and so on. You can find under root 2 under root 2, 2, and in this way you can find the sequence of this function. What is the range? Range of sequence xn. So it is 1 under root 2 under root 2 under root 2 and so on. So these are some examples related to sequence and range of sequence. Now we have to check whether this sequence is bounded or not. So yes, first one, is this sequence bounded? Is this sequence bounded? Yes, it is bounded. It is a bounded sequence because if range of a sequence is bounded, then the sequence is said to be bounded, and it is a singleton set. So all the terms are lies. If we think about geometrically, if this is C, all the terms of the sequence, you can take any real number uh, around this C. So we get all the numbers x1, x2, x3 are lies within two real numbers, m and minus m. So this sequence is bounded sequence. Is this sequence bounded? Yes, this sequence is also bounded because it lies it the terms of the sequence are 1 and minus 1. So you can take any real number, let it be 2 and minus 2. All the terms lies between 1 and 2 and minus 2. So you can take any real number 1.1, or you can take 1. So 1 also. So all the terms are less than equal to some number m. So this sequence is again a bounded sequence. Or because finite set is bounded set, and finite set is bounded, and range of this sequence is finite. It is 1 and minus 1. So range is bounded. If range is bounded, then the sequence is bounded. So we can here range is singleton set is bounded set. So range is bounded. So it is a bounded sequence. Here again range is bounded. It is finite set. Finite set is bounded. So it is a bounded sequence. Now in third you can think about this example geometrically. It is 1, 1 by 2, 1 by 3, 1 by 4, and so on. And it goes to 0. So all the terms are lies between 0 and 1. So all the terms lies here. All the terms of the sequence lies. So it means if we take any real number m, then all the terms of the sequence lies between m and minus m. So it is a bounded sequence. So yes, it is a bounded sequence. Now fourth one, xn equal to 2 raised to power n. So if we talk about this example geometrically, then this is a real number minus infinity to infinity. So first term is 2, second term is 2 cos square 4 and 8 and so on. You can take any number. If we take any number m, then minus m lies here. Then there is a term of the sequence 2 raised to power m which is greater than this number m. So if एक भी टर्म अगर सीक्वेंस की उस नंबर के बाहर आती है, then sequence is not bounded. It means हमें bounded देखने के लिए क्या देखना होगा? All the term of the sequence lies between m and minus m. But हमें इस m के corresponding 2 raised to power m जो है वो उसके बाहर है. So therefore take any m as large as possible. You can get a term of the sequence which lies outside this m. So yeah, or we can say the term of the sequence is bigger than m. So this sequence is not a bounded sequence. So this is not a bounded sequence. Now you can think about this. Is this sequence bounded? You can take any number minus infinity to infinity. This is set of real number. Now we can define. We are able to find uh, that this sequence is bounded or not. So let us construct the sequence. X1 is 1, x2 is 2, x3 is 3, and so on. Take any number n. If we take this is m and this is minus m. Now we have to find that all the terms of sequence lies within minus m and m. But there is a term, there is a number m plus 1, that is a natural number n, which lies outside this m. So we can say this sequence is not bounded sequence. we are not able to find any positive real number m such that all the term of the sequence are less than equal to that m. Mod of the sequence is less than equal to m. So it means this sequence is not bounded sequence. So this is not a bounded sequence. So we will discuss about bounded sequence, bounded above, bounded below, LUB, least upper bound of the sequence, greatest lower bound of the sequence in our next lecture in detail. But you can think about how we can define geometrically that the sequence is bounded or not. Revise all the content of the of today's lecture, and we will discuss the other part of this lecture in my next video lecture. So for the time being, you revise all the content. Thank you. Have a nice day. Stay safe. Stay healthy.